Good morning. Welcome to the is it lunchtime yet part of the conference. For this session, as he said, I'm going to be talking about hacking with Python or automation during penetration testing. Kevin gave a great talk this morning about defending against hackers and avoiding vulnerabilities in your framework. So now I'll talk about actually exploiting some of those vulnerabilities, but with a bit of a focus on Python itself. So who am I? A little bit about myself. Like I said, my name is Nat Shere. So the timing here has been a little bit awkward because actually as of last week I'm no longer employed with Rook Security, but until last week I was a senior security consultant with Rook Security, and the slide was already made, so why change a good thing? And then I've specialized specifically with web application penetration testing, so web applications, hacking, and then from day one at Rook, I was doing some pretty heavy Python scripting as well, because you really can't do penetration tests without trying to improve your automation and efficiency, and almost always that comes in with Python. So just in case anybody's not completely familiar with it, penetration testing or ethical hacking, simulating a malicious hacker, targeting your specific resources, and those resources could be network hosts, web applications, or even employees or office locations. And there are different types of testing. You might have heard the terms, white box or black box or those kinds of things. It all just depends on how much advanced information the testers have when they're starting. So in a black box, you don't have any information. White box, you have any and all information that you might want. Now, because I will talk a little bit about hacking and some Python scripts that you can use to do that, I do have to start with a small disclaimer. If you didn't know, hacking without consent is illegal. Please don't do it, okay? So I think I've absolved myself from all responsibility there, and nobody's going to sue me. Okay, great. So penetration testing and Python. So why is Python so synonymous with penetration testing very often? Well, I'm probably preaching to the choir here at this conference, but simple learning curve, right? Python is very easy to get started with. The syntax is amazing, particularly if you already have some programming experience. You don't need to kind of learn that programming mindset. Batteries included, very powerful, libraries that just come pre-installed. And then, Linux is going to generally be the operating system of choice if you're a hacker for various reasons, and that would be a whole other talk. So Python comes, pre-installed on Linux as well. And then finally, Python saves a lot of programmers' time. That's a big, big deal. So I know Kevin talked about vulnerabilities and frameworks, from a developer perspective this morning. From a pen testing perspective, we love frameworks. Anything that has, tremendous functionality that can make our jobs that much easier and faster. There are tons and tons and tons of resources about Python and pen testing, again, for the reasons that I just discussed. The Black Hat, Gray Hat Python series are fantastic. This is just a small sample. The list goes on and on and on. If you just do a quick Google search of Python and pen testing, or Amazon, of course, tons and tons of stuff. So a quick example here of why Python is so amazing for pen testing. So here, in 8 to 9 lines of code or so, is a Python port scanner. I think fairly technical conference here, so people should be fairly familiar with how ports work. But just in case, very quickly, if you have a server, any service that you're going to be running on a server has to be running on a specific port. So your HTTP server, your HTTP service, your FTP service, your mail service, anything like that, it's going to be running on a specific port. So first step as a hacker is to determine what services are running, and that means what ports are open and listening for connections. Within 8 lines, you have a working port scanner to specify the number of ports you want to test, and it'll tell you which ones are open and which ones you can start hacking. From the web application side, again, any web application that's worth going after is probably going to have a login. Easiest way to get past a login, easiest passive way to get past a login is to perform a brute force attack. In 8 lines of code, you have a working brute force script. Now this one does use the third-party library requests, but if you're using Python and not using requests for web traffic, you should. It's amazing. But even if you did want to use the just native URL lib library, add just a couple lines of code. Again, super quick, but super, super powerful for your pen testing. Okay, so now I'll start going into more of the pen testing process a little bit and talk about, how Python and automation can help at each step of the way. So at a high level, I don't want to get too deep into pen testing itself. I want to keep it focused on the Python. But at a very high level, your pen testing process is going to consist of your 3 steps. Reconnaissance, finding all the information you possibly can about your target. Exploitation, that's when you're actually doing your hacking. And then finally the reporting, the most important phase really for the client, as Kevin was talking about this morning as well, is the final report, right? Ultimately, we want to fix the vulnerabilities. Nobody just wants to be hacked with, for the fun of it. So that reporting is very important as well. So the first step, of course, is reconnaissance. And in reconnaissance, we're going to be looking for any and all information that we can find about our target. So if it's the whole company, anything, the company news, organization chart, employees, all those kinds of things, no matter the target, email format, email addresses, very often those are then the usernames that are used for your corporate services, and then passwords if it's possible. If it's a web application that we're targeting, domain names, some of the subdomains that it might interact with, and developer repositories. Very often you have your developers, posting questions on Stack Overflow. Says, this code is not working, I'm not really sure what's going on. That's fantastic, and hopefully they get the help that they need, but from a hacker's perspective, that's probably the code that I'm trying to hack right now. So if I can find that question and see actually the source code for that, it might make that step just a little bit quicker. So again, this is a lot of information. Of course, these lists could go on and on and on, depending on what you're looking for. Python comes in to automate some of this process, and of course, there are frameworks out there to help as well. 2 of my favorites, Reconnaissance and Spiderfoot, both written completely in Python, both modular-based frameworks. Reconnaissance was actually presented by the developers a couple years ago at Black Hat, and at that conference, they used FBI.gov as their target and showed within 30 minutes how they went just from that domain to email addresses and former passwords for FBI employees in plain text. And then Spiderfoot is also very good. Not quite as powerful as Reconnaissance. It doesn't find passwords like Reconnaissance does, but it does do some other really good stuff as well. It's a little bit better with finding documents and discovering metadata, which is very useful as well. Reconnaissance, a little bit dark here on the background here, but the banner welcome banner there is on the left. On the right is one of the modules currently running. It's the profiler module. This takes a username and checks dozens and dozens of different websites to see if that username is being used on those websites as well. Again, a very, very quick and good technique to discover, hey, if I have a specific developer that I'm targeting, does he have different accounts on, say, Bitbucket or Bugcrowd or something like that, and I can look at some of the information that he's posted there and just get a better profile for the different developers and the different teams that I'm targeting. Because Reconnaissance is modular based, here is a full module. This is a complete module, and it's only 33 lines of code. If you take a look, even the 33 lines though, really start at line 17. The rest of it's just kind of metadata to help you understand what's going on. This particular module runs against the API haveibeenpwned.com, which takes an email address and lets you know if that email address is associated with any breached credentials from any data breaches in the past several years. So again, very helpful. You can then, that helps get to passwords, potentially plain text passwords, because you could see, hey, I checked this email, it was in the Adobe breach, let me go check my Adobe database and see if I can get that hash. And then Spiderfoot also is very modular based. Here's just a short list of some of the modules. Like I said, not everything is as powerful as Reconnaissance, but the ones that are, metadata is one of my favorites because it is a terrible, terrible pain. Even with Google search or Google hacking, you can specify a file type. Say, I'm looking for PDF, or I'm looking for docx files. Even with that, you could be looking at dozens and dozens and dozens of files. This pulls all of them very, very quickly, checks them for metadata, and then can give you usernames or the different technologies that they're using. It's always one of our favorites is looking at the metadata and discovering, oh, they're using, Office for Mac or something like that, and then, tailoring it, taking out all of our Windows exploits and just throwing in Mac ones. And that always throws our clients for a little bit of a loop. Oops. Both of these excellent frameworks. So Reconnaissance is command line based, kind of like Metasploit if you've used that one. Spiderfoot is web-based, nice UI for users. It uses CherePy as its web framework. Reconnaissance uses Flask. I don't want to get into a Flask Django debate here, but again, very few requirements, very powerful frameworks for automating that reconnaissance. So you've used one of these. You've used manual process and wasted weeks and weeks looking for all the information that you can. So now you're going to try to move into actually exploiting. So like I said, any application or network service that is going to be worth going after is probably going to have a login portal. Basically, you're going to taking a look at login portals. You've got 3 steps. Probably just find valid credentials, which goes back to the reconnaissance or perhaps brute forcing. Exploiting the vulnerability in the login functionality, and that's very often going to be SQL injection kind of stuff that Kevin talked about this morning. Or you just circumvent the login functionality, and that's probably going to look at social engineering or something like that. So, first step, find valid credentials, right? If you have found valid credentials through your reconnaissance, great, your job is done. You log in, see what you can see in the application, and write your report. Engagement complete. If you did not, then most likely you're going to be looking at a brute force attack or something like that to see if you can gain access. Now, that will work if you are targeting a kind of typical application. You can use your template script to perform your brute force attacks, very nice. But what happens if you have a very custom-built application with a custom-built login portal? We had a client come a couple of years ago, and they said, we want you to see if you can get into our website. And we said, okay. We pull up the website, and we just see a grid of images, kind of like this one. My first thought was it's some kind of memory matching game. I wasn't really sure what was going on here. So we started clicking around, trying to determine what was going on, tried to trigger some functionality here. And we discovered, we started clicking around, clicking on different images. When we clicked 5 times, we suddenly got the error message, invalid login. Well, that was interesting. So we started looking then at the HTML source code. We took a look at the JavaScript files, some of the network traffic, and we realized, okay, actually, 5 images here is the login sequence. There's no username, there's no password, it's just 5 images. Looking at the network traffic, we realized, okay, it's not sending the images as the login password either. What it's doing is in JavaScript, it's got each image corresponding to a number. So the recycle icon, for example, in the top left is number 1. The bow tie is number 2. The ship is number 3, etc., etc., etc. Well, I don't think you have to be particularly statistically minded to see there's not that many possibilities here, right? Again, you can't click on the same image twice. So it's 5 distinct numbers, 28 possibilities, which gives you a little under 12 million total possibilities for your password sequence. With a typical laptop, that would take about 4 hours to work through all those possibilities. Well, it's very custom-based, right? We don't have a script to do this as it was. So we pulled out some Python scripting, used requests, used iter-tools to iterate through the possibilities. Took about 15 minutes to write the script, another 15 minutes to test it, make sure that it was working. And then about 4 hours to perform the brute force attack. We didn't even actually let it run for 4 hours. We let it run for about an hour, hour and a half. We went to lunch, we came back, we saw we already had about a dozen credentials. The 6th or 7th of which I believe was the administrator. So at that point, it was done. You just simply stopped the script, we logged in, and the administrator had access to the database, within the UI itself. So it was done at that point. So there we go. So we wrote the report. So we could see, we wrote the report, submitted to the client, and that was a good day for us. So that was a successful brute force attack. Generally, though, brute force attacks are really, really bad because they take forever. You're trying basically a huge list of passwords and just hoping that you get lucky, right? And your success really depends on two things. One is a weak user password. If a user is using password or let me in or secret or something like that, sure, you're going to get that really, really fast. If they're using something a little bit more complicated, like football is great, okay, that might be later on in your dictionary, but it's going to be towards the end if it is at all. If they're using 25 characters, totally random, you're probably out of luck. So you can't really control the user passwords, but what you can control is your password list. Now, if you just take a template list, most likely it's not going to be there. But users choose passwords that they can remember, right? So very often that's going to be something that's personal to them, whether it's their birthday, their spouse's name, their child's name, or something like that. So again, as opposed to just using a default password list, Python comes in and there's the CUP framework, Common User Passwords Profiler. Essentially, it takes those common words that are for a specific person, right? Name, spouse's name, child's name, pet's name, company's name. You can even throw in some extra words there at the end, like hacker or Python or something like that. It'll essentially mangle them, so to apply the various tricks that users very often apply, like an exclamation point at the end, capitalizing the first letter, throw in a number at the end, things that things that people think they're being tricky with, right? So change an O to a 0 or something like that. So it performs those permutations and then gives you a list there at the end that says about 90,000 words, right? So that's just one example to try to make your password list a little bit better. So great, so if that works, you brute force your way in, great, again, you see what you can see, you write the report, you're done. But if that still doesn't work, so now you've got to move on to exploitation. Most common for login portal would be SQL injection, and again, Python framework to help with that is SQL map. Anyone used SQL map? No? We use it pretty much every engagement. And again, so Kevin was talking about this morning, you throw in a single quote and a couple of quotes here or there, see if it triggers an error message, and that's a good sign of SQL injection. So SQL map essentially automates that entire process. You give it the URL, you give it the parameter that you are trying to inject, and it runs through all of its various tests, and then at the end, once you know, yes, that parameter is vulnerable, here's how it discovered that it was vulnerable, and then very often it gives you a couple of options, like list all the tables, list the users that are in the tables, or even just drop all the tables, which from a pen testing perspective is not a good option, particularly if you want to get paid at the end. So SQL injection, if you're able to simply exploit the login functionality, great. Again, you get in, you see what you can see, you write the report, and you're done. But very often, and I know Kevin made it sound like this morning, every single application is vulnerable to SQL injection. Not quite my experience, but a lot of them are, but not all of them. So if you get an application and actually, okay, at least from the login perspective, it's working well, right? No SQL injection here. So we'll try to bypass the login or circumvent the login. Now, Python has a very nice, basically one-liner to create a reverse shell. All we have to do is get our target user to run this on their computer, and we have a reverse shell, essentially giving us arbitrary remote code execution into their computer. And now we've bypassed any login portals that we need, that are between us and their host, right? So if we get this to run on the server, all the better. And I know this looks like a lot, but it's really basically very simple. You have your import, couple of import native libraries at the beginning, your host, right? So this would be the hacker's host that it's basically reverse tunneling back to. And then the actual command that you want to run, in this case, a shell script to give us that remote code execution on the target server. So this, of course, works fantastic if Python is installed on the target computer that you are trying to hack. Now, more often than not, it's actually not, because Python's not installed natively on most Windows machines. Fortunately, Python has a solution. There is a framework, again, Py2exe, that says, okay, I'll just take your Python file, whatever Python coding you want to use, whatever native libraries, external dependencies that you want to use, and just translates the whole thing into an executable file. They don't have to have Python installed whatsoever on their computer. It is an executable file, completely independent, and it'll essentially run your Python code on that probably Windows machine. Now, I know sometimes you can trick clients or client employees into running arbitrary executable files. We did have a project a couple years ago again, where this was a little bit, they gave us a little bit of information before we started this social engineering engagement, and they said they just had a performance review performed. So we said, oh, that's interesting. So we sent an email to all of their employees and said, you know, here are the results of your performance review. Just download and run this file. That is a .exe. It was wildly successful. Nearly 50% of the employees ran it. Our favorites were the ones that, so obviously we didn't have a performance review, so it just triggered basically an alert box and made a reverse shell for us to log in. Our favorites were the people who saw the alert box, the error message, and then tried it again, and again. And we had people try to execute this file 4 or 5 times. Actually, they had a bit of a headache because we had to go and figure out which reverse shells were then duplicates or whatnot. But they really made it easy for us. But for the most part, I think there's some user awareness to not run arbitrary .exes, or even if there's not, you know, very often your client, your company network or whatever will just block .exes in email. It's not going to even allow it. I know Gmail doesn't allow .exes as attachments at this point. So you got to find another way around, right? We talked about cross-site scripting at the beginning as well. So we had a client application again that it was essentially a social media type application targeting a specific kind of user. So they had functionality essentially to email users within the application, right? So as opposed to using, you know, Gmail or something like that, something established that, you know, has performed these security checks, they just coded their own email platform within the application. Well, it was vulnerable to cross-site scripting everywhere, just everywhere. And so we had the cross-site scripting this morning. If you're not quite familiar with cross-site scripting, essentially it's remote code execution within the web application. So you can execute any arbitrary JavaScript within another user session. And very often that will be used to then steal session cookies that will let you just log in and hijack their session. Or you can perform arbitrary commands for them. We talked about cross-site request forgery this morning as well. Everything's already been covered. We talked about cross-site request forgery this morning as well. That also will allow you to perform actions as a different user, and you can trigger those with JavaScript. It's a lot of fun. So essentially, we sent a message kind of like this to all of the, to a couple of targeted users. Said, you know, greetings, you know, again, it's a social media application, so it's kind of this benign, like, hey, we kind of want to connect with you, whatever. It's not LinkedIn. I'm not hiding that, okay? But it's kind of like, something kind of like that. So we said, you know, we kind of want to connect, you know, introduce ourselves, but in the subject line, we had this script, you know, download our malicious JavaScript file, script tag. And we realized you could put it in the body as well, but that meant they had to actually open it and read the message. If you put it in the subject tag, then it executed as soon as they loaded their inbox. So that one was a little bit more exciting. So obviously, right, so we could put actual code here within the script tags. Or we, you know, use our source file and we'll just download our JavaScript from our website. But obviously we need a server to do that. Well, again, Python comes in and very nicely has a one-line, you know, Python -m symbol HTTP server, run it on port 80, boom. You put your worm.js file there in that folder, and you can, and anyone can access that if they have a particular URL. Obviously, I had to use sudo in order to do it on port 80. That's a privileged port. You could do it on port 8080 or something without root privileges there. If you really wanted to. Very nice little library. You do have to be careful there. You do have to be a little bit careful there if you don't have an index.html file in the folder you're running that from. then it'll just list the directory that you're in. So obviously be a little bit careful with that. Again, just, sometimes as a hacker, I'm not so worried about my own security, for better or for worse sometimes, but so again, just you have to be careful with that. Okay, so but then through the social engineering, you get your access, you're able to see what you see, and now you're ready to actually write up the report. The problem is, very often for penetration testing, is that you're using all these disparate tools, right? It might be Burp Suite for applications, Nessus Tenable for network scanning, Nmap, right, is the basically industry standard port scanner. So you're using all these different tools, and now you need to combine the results. Well, these tools very often don't just produce, nice HTML or nice PDF reports. Very often they just spit out XML results. So now you take Python again. This is actually my first project on day one, was basically writing a Nessus parser to take the Nessus results and put them into a spreadsheet that was formatted nicely. So import parse, then that's it. DOM equals parse, you parse the XML, and then you can just iterate right through the XML objects. And obviously this would go on here, obviously, to whatever results that you wanted to find. So that is, this is then combining outputs from multiple sources. Sometimes we're using OWASP's, blanking on the name right now, OWASP's web scanner, and then Burp Suite, so those sometimes would have the same results. Fuzzy Wuzzy was one of my favorite Python libraries for a long time, basically combines, does string, basically parsing, string matching, if it looks kind of the same, so you can combine vulnerabilities or combine results like that. And then Python also has libraries for any possible output that you could want, your basic CSV, XLSX. We actually, since that first day, took all of the those Nessus parsers, basically combined them into then being able to create this beautiful XLSX file, including looking at different Nessus results, and then basically performing a vulnerability management analysis to show you, okay, you've got these vulnerabilities in the first scan, then these vulnerabilities went away, but you introduced these new vulnerabilities, and all these kinds of things. That library also lets you do graphs and basically anything that you possibly could do within the Excel application itself, you can do programmatically. DocX, again, basically take whatever Python results you want. Anything you could do with Microsoft Word, you can do through DocX, and then even PDF, right? So final output, whatever that might be. Cover a couple of the questions here. Yes, I am with a new security company starting next week. Thank you very much. PowerPoint slides, yes, I believe so.
Yes,
yes.
Colleen will do that.
There you go. And were you ever able to get into a two-factor protected account, e.g. by social engineering the token from someone? That is a good question. No, I have not, personally. I'm trying to think if any of my coworkers ever did. I don't think we as a team have hacked a two-factor protected account. We've gone, other means, basically, again, bypassing the login, but we have not exploited a two-factor itself by social engineering the token from someone. Any other questions? Sorry? Do I know anybody who has? Are you looking for pointers? Not personally, no. Generally, we avoid DoD websites because they don't hire us. We did have a client who gave us a huge list of IPs, and then we always verified, tried to validate that they actually own the IPs that they gave us, and I think 6 of them came back as DoD websites. So that was a sit-down talk that we had with that client before we started testing. But yeah.
Very interesting. Okay, one more question, Catherine.
Does anybody have semi-lockdown virtual machines to practice against targets that won't get you arrested?
So the question is, does anyone have semi-lockdown virtual machines you can practice on so you don't get arrested?
Yes, absolutely. And it kind of depends on what you want to practice. I'd have to go back to my notes later, wonderful website that just lists tons of virtual machines. Are you?
I got you. Damn vulnerable web app.
So that's an example of one. But I was thinking there's a website that lists like capture the flag virtual machines specifically designed so you can download it and practice something specifically. But then, yeah, if you want to practice web application hacking specifically, there's damn vulnerable web app. OWASP has one. WebGoat, I think it is.
OWASP costs money though. It's like they charge like $800 for like 60 to 30 days or something like that.
I think Google even has one. So he was saying OWASP actually charges for it.
Facebook has one someplace, I don't remember where it's at.
Yeah, they are there. So if you do a couple of quick Google searches, if you don't find it, I've got lists somewhere.